So this is the continuing point of that Chapter 9 focused reading you guys did on Friday. I wanted to put this together to talk a little bit about kind of receptacle spacing in a house and some switch requirements. And so I thought I would do a short video for you, and you can watch this video, and then there's a couple questions that go along with it as well. So the first slide here talks about the electrical symbols, and usually what you're going to see for symbols is you're going to see a symbol that looks like this, and that is a receptacle, and sometimes we call those outlets as well. But notice an outlet, this definition comes right from Article 100 in the front of the NEC. An outlet is a point on the wiring system at which current is taken to supply utilization equipment. So really an outlet specifically, I mean, it could be a light, it could be a receptacle, it could be a motor, it could be anything that utilizes electrical current. So this outlet is kind of a broad term. So sometimes this is in fact an outlet and refer to that as an outlet. So we've got an outlet symbol, and then we also have the switch symbol. If it's just an S, it's a single pole. We have an S with a 3, there's a 3-way. And then we can also have an S with a 4, there's a 4-way. You can have an S with a D, which represents a dimmer switch. Or you can have an S with a small F by it. That's for a fan. Lots of different types of switches. Typically, when we're talking about switches, it's important for us to look at this number here along with it, or a letter, because that will kind of further define the type of switch and what it's going to be used for. So when we're talking about a residence and we're laying out circuits and we're talking about where to locate receptacles, the big code article that we're going to reference is going to be Article 210.52a, and then it's going to be 1 through 3 are the requirements for receptacle layout. And the next slide is actually that page from the code book, so we'll look at it a little bit more here in the next slide. But those requirements come from the NEC, and we're talking about duplex receptacles. And this bullet point here in the middle, we're talking about a one switched and one hot. They're talking about a split wired receptacle. And if I were to draw that symbol varies just a little bit. I'm going to draw the same symbol, but then half of this circle typically is colored in, and that denotes or is the indication that that's going to be a half hot, half switched receptacle. And this requirement right here is the one we're going to follow. This is from 210, where it says any point along a wall should not be more than 6 feet from the nearest receptacle outlet. So ultimately that means we can go 12 feet between receptacles. So I can have one down here and I can have one down there. It'd be 12 feet, because if I stood right here in the middle, I would be 6 feet this way, and I would be 6 feet this way. So that is a little confusing, but that comes to us from Article 210. So here we are at Article 210. This is the section I'm talking about right here. Whoops, I think I went a little bit too far. Sorry. We're actually not quite that far down, because we're going to stop here where it says number 3 is floor receptacles. Okay? So those are our spacing requirements when we're dealing with wall space. We had a question the other day when we talked about glass panels and room dividing glass panels. There's some special things we need to do for those, but basically we're looking at any wall that's 2 feet or longer needs to have a receptacle on it, and those spacing requirements are found here in 210. We're also going to have some requirements in regards to kitchens and small appliance. So number 4 here talks about countertop receptacles and receptacle outlets served and we're going to specifically look at this section right here: wall top counter spaces, island counter spaces, peninsula counter spaces. And so those are covered right there. And that tells us that we're going to be looking at 24 inches, so no point farther than 24 inches. So again, we're looking at 4 feet apart. We stand in the middle. We go 24 inches. That's going to be our receptacle location. If we have an island, sometimes the kitchen will have an island out in the middle. We have to have a receptacle on the island. And then also, occasionally, we're going to deal with the peninsula. The next slide will hopefully kind of clarify some of that as well too. So here's an example of a kitchen space. So we'd have a receptacle there. Because of this sink, our spacing is going to start over again, and so we would have a receptacle on this side of the sink. Same thing here. This sink right here. So our dimensions would start here, receptacle out here. We would stop because of the sink, and then it would start again there, and then we would have another receptacle over on this side of the sink. We also have to have receptacles in bathrooms, and the bathroom, we're going to have a bathroom sink. We have to have a receptacle located near it, and it has to be within 3 feet. And so that requirement is right here. This page is Article 210.70, and we're looking at A here, habitable rooms, and also number 2, additional locations. And this basically tells us that we have to have switched control lighting in habitable rooms, and it kind of defines what a habitable room is. So that's our requirement for determining which room is going to need to have lights, and ultimately if they are switched controlled. Here's a good example of just a small room you'd see on a blueprint. And we have the switches there. There's 2 3-way switches controlling that light fixture. And then notice there's a couple of receptacles here. There's one there, and one there. Now sometimes you may see lines that actually connect the receptacles together too, as far as how those circuits or how those receptacles will be connected together. Or sometimes, let me get rid of this line. Sometimes another way folks will do it is they'll actually have the circuit number next to the receptacle. So maybe they'll put a 3 by each one. That'll mean that that's circuit number 3. Or maybe those 2 are 3 and this one is number 4. You may see something like that. In addition, you might also see that circuit number here as well. So this might be circuit 4 as the feed for that light. Okay, so a couple things you'll find on the blueprint in regards to symbols and how things are labeled on the print. Here's a kitchen layout. Gives you an idea of kind of what some of these terms are that we talked about. Here's the island. Notice it's out in the middle of the sea of the kitchen. We've got a peninsula. And of course, peninsula is always easy for us to understand here in Michigan because we live in a peninsula. So there's the peninsula section of the countertop, and then you can see the different receptacle locations all the way around the kitchen. This backside here, they have a wet bar, so that's a whole nother system, but we're just kind of focused from this wall this way. A couple other receptacles over here. Now, one thing I try to do when I'm doing kitchens is I oftentimes think about how people use that space. And so I might have this circuit as circuit 1, 1, 1, 1, and then the next circuit 2, 2, 2, 2. Notice how I alternate between the two circuits, because if someone is standing here working, they have two separate circuits available to them. They can either be on the blue circuit or the red circuit. Same thing is true over here. If we're standing here working, we've got the opportunity then to be on circuit 1 or circuit 2, or circuit 1 or circuit 2. So that means when you're dealing with high load equipment, blenders, toasters, and those types of things, you have options as far as what circuit will be plugged in, and there's less chance the overcurrent device would be tripped in that situation. And then remember too, we have to have a GFCI over here, and we would have a GFCI at that location, and that would give us protection throughout all of those receptacles.